Okay, this is the third part in the series, so I'm not going to give an introduction, but what I've done is I've replaced the solenoidal coils that I was using before, these ones, solenoidally wound. I've put the normal Orbette's drive coils back on, but to avoid complicating matters, I've left off the biasing magnets. So all we've done is just swapped the solenoidal coils for toroidal coils. I have also not changed the timing from the last part of the last video. So everything's exactly the same. I'm going to go ahead and plug in the power. Okay, and there's the voltage drop in the current, and I'm going to give it a little spin in the clockwise direction, and you'll see that it does run, but weakly. Right? And in the counterclockwise direction, it does not run. Okay, now if I switch the polarity of the coils, still runs clockwise, but weakly. And in the counterclockwise direction, it does not run. Okay, so look at that. It switched direction and now it's running clockwise by itself. Okay, so reversing coil polarity doesn't affect this motor. See any change in speed there? Right? But if I go the other way, I started it going counterclockwise now. Switches down one polarity. Switch the other way. Okay, switch this way, going this way, clockwise. It runs, but weakly. And if I switch polarities, still runs, but weakly. The reason it's running weakly is because I don't have it in the correct timing spot. So I'm going to go ahead and see if I can find the sweet spot that will make it run in one polarity or the other. Might have to really advance it. There we go, I think. Okay, so let's just go ahead and time it visually, as it should be timed if it were a repulsion motor, a core effect Orbo motor. So we want it to fire just at top dead center, and that's firing quite a bit early. So let me retard it a little bit. That's actually pretty close. Okay, so the dwell is way too short. That's what it is. Okay. I don't really have very good control over the dwell with this setup. That made it longer. I just physically repositioned the Hall sensor so that the core effect would come on and stay on a little bit longer. Okay, so now it should work better. And once again, there's no noticeable effect of swapping the coil polarity. And let's see if I can get that sweet spot a little bit better. Okay. Oh, I know what it is. I'm expecting it to have the kind of speed that it gets when it has the biasing magnets on it. That's what it is. So let me just go ahead and put those biasing magnets on there. Excuse me. Now these are the biasing magnet sets, and if I can put those in position. Now there is, just with the one, you can see that there's a strong effect of core polarity now. It spins more slowly in one polarity and starts accelerating in the other polarity. And the other set of biasing magnets there, and now it really takes off. Passing through 37 hertz now. Got a little knocking and rocking in there. Let's see if I can find the sweet spot again. 42 hertz. Yeah, 44 hertz. Now it's slowing down. Go back the other way. 43, 43.5, 43.7, 44, 44.5, 44.8, 45. So somewhere right in there is the sweet spot. And now what I'll do is I'll switch the polarity again. And it slows down. 30, 29, 26. 16, and then it goes the other way. So maybe the the biasing magnets actually turn this into some kind of strange pulse motor. But I think it's still working by core effect myself. Alright, so basically what we've done is we've used the biasing magnets to optimize the Orbette's performance in one particular core polarity. But if we take the biasing magnets off, then we can see that Orbette is working as a pure orbo motor that is working by core effect interactions rather than repulsion or attraction. And we can see that switching of coil polarity has essentially no effect on that. There's a little bit of an effect. I'm seeing, like, this is 16.8 hertz, and then when I go the other way it speeds up a little bit, 17, 17.3, 17.8, 18. So it's stabilized at about 18.8 or 9 hertz. It's still slowly gaining speed. And in the other direction, it stabilizes at a slightly slower speed. But if you were to simply start the motor by hand, you would see that in this polarity, it doesn't run that way, and it does run this way. And in the other polarity, it doesn't run this way, and it does run this way. So what I call the FFT, the fumbling finger test, is not a good way to tell whether your coil polarity switching is having an effect or not. You have to do it live, and you have to do it with a good precise indication of what your speed is. Thanks for watching.